The Piedmont Hospital Surgery Suite project is a 3-year healthcare construction renovation consisting of 57 phases. It involves renovation of an entire surgery suite within a major metropolitan hospital. This project is unique and presented itself with the logistical challenge of having to gain access to construct 7 complex ORs lying within the heart of the surgery suite. As you view this video, keep in mind that in order for Skanska to keep the surgery suite up and running, could not access these 7 complex ORs from the same level of the build-out.
This is an outline of the Phase 2 Surgery Suite project and some of the areas surrounding the Phase 2 construction area. The corridors highlighted in yellow show surrounding perimeter corridors, several of which were sterile, restricted corridors, staff-patient corridors. The red area you see are existing ORs that remain in operation during the Phase 2 construction. The green area shows the OR satellite pharmacy and several OR offices. The area directly in the center in white is the Phase 2 construction area. As the model rotates around, you can paint a clear picture of how isolated Skanska was during this phase of construction. We were totally surrounded by sterile corridors and existing ORs that remained in operation during the entire duration of this phase. Basically, we were on an island with no way to get personnel or material into or out of the construction space. The first step of any healthcare construction project is to get the infection control measures set up. Get your dust walls, top out, and negative pressure in place before any work can begin. The sections in blue surrounding the construction area show walls being topped out, and on the left-hand side is a dust wall we constructed in a sterile corridor to isolate us from the surrounding OR space. One challenge Skanska was faced with was trying to get layers of electrical conduit from an electrical closet over to the complex OR area. Due to one of the main staff corridors that was required to stay in operation 24/7, the hospital would not allow this corridor to ever be shut down. In order to bridge this obstacle, Skanska constructed a temporary tunnel so the electrician could continue to work overhead and the staff could still utilize their corridor.
Now that we are in containment, obtain negative pressure, and have our infection control program signed off, we are ready to start construction. The first step involves demolishing the interior walls that you see here. Then we need a way to get both materials and workers in and out. So let's take a step back and look at the roof above. There's our footprint. You see on the right-hand side we left the space out for the portal we need to place to gain access in and out. Our first step was to determine the best location to access the roof from below. We landed our buck hoist out in front of the circular bump seen here called the McDonald Surgery Center. To the left is the main loading dock in operation 24/7. We were able to build a ramp, not shown here, coming from the loading dock to the buck hoist. Workers could access the buck hoist and bring their crews and materials safely up and down. At the top of the hoist, we could access our catwalk provided for protection to the roof. Off to the left, you see additional access to the trash chute and dumpster, which pretty much stayed in place during the 3-year duration of the project. With access to the roof and dumpster in place, we move on to our portal unit and system for getting workers and materials inside the project.
This portal unit is where all the materials either came in or out of the space below. As you can see, it has steel framing, wood studs, and wood sheathing and roofing. This is what the portal unit looked like from the outside. To get a better understanding of what made this unit operate, let's take a look at the interior components. Our first step was to install a ladder so all personnel could gain access into the construction area. The hole shown on the right-hand side is where all material was coming in and out of the space, and railings were constructed to protect those openings. What you see here is an outline of 2 doors, one located on the ground construction level and one on the roof level. One challenge Skanska was faced with was being able to control the negative pressure inside the portal unit. Basically, what we were constructing was a massive chimney which could have led to a possible infection control breach if not controlled appropriately. In order to overcome this obstacle, we created what we call a man-trap security system, where we were able to interlock the two doors with security hardware. Both doors were equipped with electric strikes, push-to-exits, and a red and green light feature that indicated if the doors were either locked or unlocked. For example, if you came up to a door, push to exit, and saw a red light, this meant that the opposite door was in an open position. The green light would indicate that the opposite door was closed, and thus you could enter into the portal unit. So these doors worked in conjunction with each other to control the negative pressure. Even with one of the doors in an open position, we were still losing negative pressure, so we installed an exhaust fan up on the roof level to help control that negative pressure even more. Now that we had the negative pressure controlled, we needed to figure out a way to move material in and around the portal unit. As mentioned previously, this unit was a steel frame structure and was constructed with a hoist beam that tied into this framing. Skanska purchased a 5-ton electric hoist and trolley that ran back and forth along this hoist beam. A gate was constructed to protect the opening, and a safety line was installed to protect this opening when the gate was in an open position. As you can see, this hoist was able to move back and forth along the hoist beam and was able to handle all material coming in and out of the construction area below. Here's an example of one of the trash buggies that ran continuously throughout the duration of the demolition phase. Skanska hired a full-time hoist operator to operate this hoist throughout the entire Phase 2 construction build-out. It is important to point out that this portal unit is one continuous structure from the ground floor up to the roof level. The ground level was constructed identical to the roof structure above, wood studs and sheathing. It was totally isolated from the Phase 2 construction area, which allowed Skanska to better control the overall negative pressure. This portal unit was so unique and had so many characteristics, we could not go without giving it a name, so we called it the doghouse.
Now that construction of the doghouse is complete, we are ready to raise the roof. From the building footprint, you can start to see perimeter block walls and columns constructed. Next comes the horizontal framing and then finally the roof on top. As we rotate around, keep in mind Skanska had to work closely with the structural engineer. The creation of the doghouse forced us to build two separate structures, the doghouse and the 6-foot raised roof portion, with the goal of eventually being able to take down the doghouse and complete the total perimeter raised roof framing. Now that the roof is complete, we are ready to demolish the existing or old roof underneath. If we take a look down below, we see the existing roof in place. Skanska self-performed the careful demolition of this roof in separate sections. Once completed, the hospital now has 5.5 foot of added space to house their structural steel, medical equipment, and utilities. Once the punch list was finished and the project complete, we took down the doghouse and built back the portion of the roof. Now, the coordination up front between the structural engineer to keep the doghouse as a separate structural entity was a real help, buttoning up the remainder of the roof here at the end of the day. When we first looked at Phase 2 with our client, we didn't know how we were going to gain access and not shut down a portion of Piedmont Hospital's surgery suite. This particular challenge really forced us to step outside the box. We were fortunate to have a client who was experienced helped us to create the doghouse solution. Renovating an entire surgery suite in a major metropolitan hospital is almost unheard of. Through partnering with our client, we designed and constructed the doghouse and it allowed the surgery suite project to become a reality. Safety and infection control levels were maintained at all times, and doctors and nurses kept operations ongoing with zero impact to their patients and staff. The doghouse is a great example of overcoming a major project challenge through innovation and, most importantly, the commitment of our project team to one of our most important long-term clients.